In this video we're going to be looking at anti-differentiation or integration. So this is basically the opposite of differentiation. So before watching this, before trying to understand what anti-differentiation is and integration, it's really important you have a good understanding of what differentiation is and how to do it. And once you do that, then you can look more at anti-differentiation. And that's because you don't want to get them confused, as well as once you know differentiation, then anti-differentiation will become a bit easier to learn. So if we have y equals 6x squared, then dy dx, so the gradient or the derivative, is equal to 12x. We brought the 2 down, and then we divided by 1, so we got 12 on 1, which was 12, so we got 12x. So what we did here was differentiation, or diff. However, what anti-differentiation is going from this number here and bringing it back to this number. So this is anti-diff. And in this video, we'll go through how to do that for some simple examples and how it's useful. So anti-differentiation, this can tell us the gradient, or the derivative can tell us the gradient. However, anti-diff can tell us the area underneath the curve, which is very useful, and it has many other applications which we'll go on and learn about. However, we're going to be looking at how you can actually go from an equation such as this, so 6x squared, to go to 12x. So we know how to do that, but how do we go the other way? So what about if we have the equation fx, the derivative is equal to 3x? Then that means if we find the integral of 3x dx, so this is the notation of anti-diff here. So instead of, that's basically saying the notation of whatever the function you want anti-diff is in there, or integrate. So you have that symbol there, and then you go dx. That's with what you anti-diffing with respect to. So with dy dx, the bottom is what you're diffing with respect to, and then here there's dx. However, it may be something d something else. If it was, let's say, 3y, then it would be, for example, 3 dy. Then you can antidiff this, then you get your solution here. So if we had the f dash x is equal to 3x, then the solution is going to give us 3 on 2x squared plus c. Now you don't know how to get that yet. However, try and diff this. And when you diff this, you'll bring the 2 down, and you'll get 3 on 2 times 2 times x, 2 minus 1 plus constant, so 0, which is equal to 3x. We can see how this, if we diff it, we got to that, and how if we antidiff, we get to this. But how do we actually antidiff? So we'll look at an example. Y is equal to ax plus c. So this is just a general equation. So if we find dy dx, this is equal to a. So that means when we integrate a dx, we're going to get ax plus c. So that means if we have y is equal to 3, then we antidiff 3 dx, we're going to get 3x plus c. So we'll look at the two different components. So firstly, this component, the 3x. So why is that the case? Well, the reason for this is because we have 3 here, but now we need to add on an x, because when we diff, this x becomes just 1, and we bring the 1 down to the 3. So that's why we have to add on the x. And what about this c? So the plus c, the constant, is really important. And when you integrate, you always have to remember to add on this plus c. Why do you have to do that though? Well, when we have an equation, so y is equal to, let's say, 10x to the 5 plus 2, then we get dy dx is equal to 50x x to the 4 plus 0. We always get plus 0 when we differentiate or find the derivative of an equation. So when we have to go back the other way, we have to put this plus c in, because there could have been a constant. However, if we had, let's say, 3x plus 2, and we diff that, we'd just get it equal to 3. If we had 3x minus 4, we'd get it equal to 3. And then if we had 3x plus 0, we'd still get it equal to 3. So there's no way we can know what constant there is. So whenever we integrate, it's really important that you remember this plus c, which just represents any constant. And often there'll be additional information that you can sub into the equation, and you can work out what this actual constant is. So how do we solve it for general. So we had the ax plus c. So you know how to integrate 3 dx. You know that, or something like, or any number, that'll be 3x plus c. But you can put it in general sense, just like when we diffed. We brought down whatever the power was, we reduced the power by 1, and then that could tell us the answer. So here we have y is equal to 3 to the x to the 4 plus 2. So how do you do this? Well, if you wanted to integrate, well, when we diff this, we're going to get 12x to the 3. So if we wanted to integrate 12x to the 3, so let's dy dx. The first step is to add plus 1 to the power. So that means this is going to equal 12x to the 3 plus 1. So when we diffed, we minus 1, so it makes sense when we anti-diff, we're going to plus 1. The second step is to divide by the new power. So not the old power, but by the new power. So that means we have 3 plus 1, so that's 4. So we're going to divide by 4. So what does 12x to the 4 divided by 4 equal? 3x to the 4. However, we always have to remember, so the third step is the plus c. So here, at every step, we need this plus c, the constant. You can see that we're 3x, 4 plus 2, and 2 is a constant. So from there, we got to here. So what are the steps again? So we add 1 to the power. So that should make sense, because when we diffed, we minus 1. However, we have to divide by the new power now. So when we diffed, we divided by like the original power, but now we have to not divide by 3. So dividing by 3 is wrong. Rather, we have to add 3 plus 1, so 4, and then divide by 4. So have a try and integrate or antidiff this function here. So 2x to the negative 3. So you go through the steps. So this is equal to 2, x to the negative 3. What's the first step? Add 1 to the power, plus 1. So this is going to equal 2 to the x negative 2. What's the second step? We have to divide by the new power, so negative 2. So we divide by negative 2, and then this gives us, and then the third step is to add c, so we go plus c. This solution gives us a negative x to the negative 2 plus c, which is equal to negative 1 over x squared plus c. Now when you diff this, you'll be able to work out get the same solution. So you bring the negative 2 down, negative 1 times negative 2 gives you 2. At minus the power, so negative 2 goes to negative 3, and we get x to the negative 3, and then there's obviously not going to be a constant, so plus 0. So when you're first learning to integrate, you can always go back and check and diff this to make sure you get the same solution that you have before, and always remember the constant, because if you can start to get into the habit of remembering the constant now, then you don't have to worry later during tests or exams that you will forget it. So finally in this video, how do we graph the antidiff? Well, you can integrate it, work out the new equation, then draw the equation. However, if you think about it, when we diff something, we got the gradient function. So when we antidiff something, the previous graph is going to be the gradient function. So if we have here fx, and we say that gx is equal to the integral of fx dx, and we want to draw gx. Then this fx now becomes a gradient function. So what does that mean? Well, when it's positive, there is a positive gradient. So that means on both sides of here, there's going to be positive gradients. And all this value here will be a negative gradient. Here will be stationary points. Stationary points. So graphically, we can represent that by a positive, reaching a stationary point, going down again, so negative, reaching another stationary point, and coming up again. So we have positive, negative, positive. Now, of course, there will be the plus c. So there's going to be, unless we know what the plus c is, at a particular point in the graph, there'll actually be infinite different types of gx, but we'll all have this general sort of shape. Obviously, this is pretty rough. However, this is just so you can see how when we can use the previous function as a gradient function to sketch what the new integral or gx is going to look like in its basic features.